Hello, this is the key to the practice exam 2. First, we'll take a look at the question number 1. So question number 1 is about the probability distribution of a discrete random variable. Like here, x is a discrete random variable, right? Y is a discrete random variable because it has only like how many values? 5 actually, 0, 1, 2, 3, 4. And then the corresponding probability. And here, to be a valid probability distribution, it has to satisfy two conditions. Number one, each individual probability has to be between 0 and 1. And the sum of all these 5 probabilities together is going to be 1. Okay, obviously this is a that's why exactly how we get the probability for x equals 4, right? Because if this is empty, the whole thing is 1, then we have this one equals 0.6. Alright, how could we get the probability for x at least 2? See, at least 2 here, x greater and equal to 2. So at least 2, we could be, you can see here 2, 3, and 4, right? That's how we add those 3 probability together, 0.7. Or we could do at least 2, 2, 3, 4, and then we just do not have 0 and 1. That's why we use 1 minus the probability 0, probability 1. So both ways would end up with the same solution, 0.7. Okay, how to find the mean and the variance of x? Remember, the formula for mean is the little x times the probability for capital X to be little x, and then add all of them together. How? Yeah, because this summation, is a little confusing at the very beginning. That's why we could use this table to understand what's really going on for this summation. So first we do this cross product. So the corresponding x values, and then the probability for capital X to be that little x value, and then multiply together. 0 multiply 0.2 equals 0, 1 times 0.1 equals 0.1, 2 times 0.2 equals 0.4, and 3 times 0.1 equals 0.3, 4 times 0.4 equals 1.6. That's what we mean by x value times the probability of its corresponding probability. And then we add all of them together. That's what we mean by sum, which is 2.4. So the mean of x is 2.4. How about the variance? Variance is much more complicated. Okay, first we have to figure out the squared deviation, and then use the probability as the weights for the so-called weighted average, right? So how could we do that? And we already know mu is 2.4. So the squared deviation xi minus mu is, for this case, 0 minus 2.4, and then square it. That's how you get this guy. And then 1 minus 2.4, you square it, you get this guy. 2, 3, and 4 do the same thing. That's how we get this column. And weighted by the probability, basically times the probability. So we use this guy times the probability 2.4, excuse me, right? That's how we get this one. Yes, this should be 11.52. Okay, this is a typo. And then 1.96 times 0.1. That's how we get this number. And 0.2 times 0.16. And then we add them together, ends up with 2.44. That's the variance. Okay. And then what is the probability for x less than 0 and y? Because remember, capital X is a discrete random variable which only has 5 values, 0, 1, 2, 3, 4. So it's impossible to get a value less than 0. Okay, that's impossible. Here should be capital X. Alright, question number 2. Question number 2 is about a binomial distribution. For this binomial distribution, we need to figure out what is the n, is the number of the Bernoulli trials. What is little p? Little p is the probability of success. So in this case, suppose 4 adults are randomly selected, right? Just think about this one. Each individual adult is selected. That's a Bernoulli trial. That adult could have a college degree or not. If yes, that's a success. If no, that's a failure. This 20% is exactly the chance for that adult to have a college degree, right? So we have the n equals 4, p equals 0.2, 20%. And then what is the probability that all the 4 adults have a college degree? So this is the probability for y equals 4. So here y denotes the number of adults out of 4 who have the college degree. So we use the formula. That's how we get this probability. Okay. And then what is the probability at most 2 of the 4 adults have a college degree? At most 2 basically could be 0, 1, and 2. Okay, we just figure out the 3 probabilities and then add them together. Or we could just go the other way around, right? This is the complement rule. So for the n equals 4, right? So here y could be 0, 1, 2, 3, 4. So here 0, 1, 2, only 3 and 4 are excluded. That's why we use 1 minus the probability of y equals 3, the probability of y equals 4. Okay. Both would end up with the same solution. Okay. For part 4, we're talking about the variance, expected value, and standard deviation. So we just use the formula n times p, right? A is 4, p is 0.2. That's how we get 0.8. And then plug in, get 64, and then take the square root, get 0.8. Alright, now if we say we have 100 instead of 4 adults randomly selected, then what should we do? We could just do it by hand, but since this n is so big, right, it's 100. Take a look at this one. What is the probability less than 10 adults who would have a college degree? So here, y is less than 10, okay, the probability. So that is equivalent to probability of y less than or equal to 9. If we follow the way we did in part 2, then we have to do how many times of that kind of calculation? From 0 to 1 to up to 9, we have to do 10 times. That's too tedious, right? That's exactly we have to turn to the help of the R. So in our case, we are going to use this command here, right? That's exactly the probability for y less than or equal to 9. So this p by norm, right? That's exactly for the cumulative case, okay? But if we do the D case, that's only the probability for y equals 9, just 1 point. And here with the p, that means the probability up to 9, right? Less than or equal to 9. Alright, what if we want to know the probability at least 10? So we have to figure out the probability of y greater than or equal to, do not forget this equal sign because this is at least, right? Now say if we do it by hand, we have to keep going 10, 11 up to 100. That's impossible, right? So the common trick here, we use the complement rule, use 1 minus the probability of y less than 10. We already know this probability from part 5. That's why we plug it in. That's how we get the probability, okay? Now let's go to question number 3. Question number 3 is about the normal distribution. And if we let y to denote let y denote the score on a management aptitude examination, this y has a normal distribution with mean 72, standard deviation of 8. For part 1, what is the probability a randomly selected manager will score above 70? So we want to get the probability for y greater than 70, and then we use the transformation, transform the y into z. Z here is a standard normal. Accordingly, 70 has to be converted into a standard z-score also, minus 72 divided by 8. For this z probability, we could either get it from the z table or from the R. The same thing for part 2, right? But this is a sandwich probability. So we converted y into z, and then 66 and 82 are converted into the corresponding z-scores. That's how we get the probability. And part 3 is about inverse probability problem. We want to find a little y value such that probability of y, capital Y greater than little y is going to be 2.5%. Followed from the z case, we know the little z has to be 1.96. And then what is this little z converted from? Actually, little z is converted from y. Little z equals y minus 72 divided by 8, and then equals 1.96. So solve this little equation for y, end up with this number. Question number 4 is still for normal distribution, but here is for the sampling distribution for X bar. We have two distributions here. One is the normal distribution, where those random sample is drawn from. Okay, so this is like, I call it as the parent distribution in class. Also, we're talking about the probability distribution of the sample mean, X bar. This is kind of like the child distribution. And these two distributions, they share the same mean, 50. But for the standard deviation, the parent distribution has 12, and the child distribution, the sampling distribution of X bar, actually is the variance should be the population variance sigma square divided by n. So the population variance actually is 12 square, and then divided by n. N is 36. So we put together as kind of like that. So sampling distribution for X bar also has a normal distribution with the mean at 50. Variance here you can see is 2, because 12 divided by 6 is 2 squared, so it's 4. Variance is 4. It's 4. When variance is 4, then standard deviation is 2 right here. So that's why if we want sandwich probability problem, here we have the standardized by minus the mean 50 and then divided by standard deviation of 2. Okay? Here is 2 instead of 12, because 12 is the population standard deviation, and 2 is what? Is this distribution for X bar. Now, if we have a sample of 36 observations with mean of 48, this mean is a sample mean, right? Because we have a sample here. The population mean mu is unknown, while the population standard deviation is still 12. So what would be a good estimate for mu? Because mu is the population mean, right? What would be a good estimate for the population mean? Sample mean, 48. So 48 is a good estimate for mu. Why? Because 48 is the sample mean. Sample mean is a good estimate for population mean. As for the 95% confidence interval for mu, we just use the formula, right? Because we know sigma is given 12. so we have to use z. For 95%, alpha equals 0.05, and then z substitute alpha over 2, this is 1.96. Point numbers went up with this confidence interval. What is the probability that mu falls into the interval in part 4 and why? This is just a one visualization of the confidence interval, right? Based on the sample we're talking about here. Okay. So this mu is also a constant. For constant mu be in a constant interval, there are only two cases, right? Either in this interval, whether the true mu is in this interval or not. That's why the probability either is 0 or 1. 0 means mu is not in this interval. 1 means mu it is in this interval. That's exactly the solution here. Okay. For part 6, we already have 36 observations, right, with the mean as 48. We add 4 identical numbers of 48 in the original sample, 36 observations with mean 48. Nothing else changes. Calculate a 95% confidence interval for mu. What has changed? First of all, the sample size has changed, right? Because original we have 36, now we have 4 more. So A equals 36 plus 4 equals 40. How about the sample mean? Will the sample mean change here? Actually, it's not, right? Because you add like 4 identical number of 48 in it, in the original sample. The sample mean of the original sample is 48. Now if you add 4 more 48 in it, then the sample mean, the new sample still has the sample mean of what? 48. 95% confidence interval. This is the x bar plus z alpha over 2, right? 1.96. Sigma divided by square root of n. N in our case is 40. So we end up with this guy here. Obviously, these two confidence intervals are different. Which one is wider? This one is wider. So from here, we could just say to achieve the same confidence level, right? Both of 95%. If we have a larger sample size, we will do better. Even though in terms of the point estimate, right? X bar, the same thing. Here is 48, here is 48 also. Okay, for the last part, last question number 5, this is about Poisson distribution. For the Poisson distribution, we gotta be very careful because here Poisson distribution for this 30-day month, this time period, okay? The average visit is 18. This is a Poisson distribution with an average of as 18. How about this 5-day period? We could split this 30-day month into how many 5-day periods? Actually 6, right? Very interestingly, if we split the time into 6 periods, then this average 18 visits are gonna be split over 6 periods also. Then each period gets what? Gets 3. 18 times 1 over 6. So this 3 is the mean for this new Poisson distribution. If we know that, then what is the probability a customer visit the chain 5 times in a 5-day period? So we want to know the capital X equals 5. What probability is that? So we know for the 5-day period, the number of visits follow a Poisson distribution with sample average as 3. So use the formula, we get this probability. At least 3 times. This is the common trick, right? We use 1 minus the probabilities up to 3, or you can say less than 3. Only 0, 1, 2 are less than 3. We could use this complement rule to get the probability. I hope this video helps. Please let me know if you have any questions. Thanks for watching. Bye.